Hello, this is Shubh, explaining you the solution of first internal data science using Python. So we were given a case study, DSS on IPC BMS section mapping, a decision support system. DSS helps to find the right IPC and BMS section for the police report in India. Police complaints are usually written in the free text. They're not always clear or structured. To make them useful, the system must abstract feature. Example are how serious the offense is, whether there is a evidence what offense element are present, detail about complaints or cues. The DSS use a knowledge base of IPC BNS law. It compares the feature of new complaint with the knowledge base. For this, it needs different methods. Statistics helps in to describe complaint. They give average, range, and detect unusual cases. B. Similarity and dissimilarity measures show how close one complaint is to another. This helps in finding related cases or past examples. C. Data preprocessing kills complaint data. It fills missing values, remove error, and makes values comparable. D. Compatibility and pairing study how difficult offense element or accused person combine. This is important for cases with multiple offense or code cases. A, D are practical steps for building a DSS that can turn raw complaint into clear legal insights. We have part A, statistical vectorization of complaint data. First, give three common. Well, first question, we have three common use of statistical method to characterize this person in complaints drivers roles. Example, alleged offense, severity, evidence strength, harm, impact, injustice. How these measures can be computed efficiently over a large complaint repository. Three commonly used methods of dispersion are range, max, min, simple sensitivity outliner. Second, interquartile range, IQR, Q3 to Q1, robust to outliner, describes spread of middle 50%. Standard deviation of variance, standard deviation is the square of 1 by n minus 1, summation of xi minus x mean ka whole square to the whole square. Sample ST measures the spread around the mean, useful when the data is approximately symmetrical or normal. Fourth, efficient computation over a large complaint repository. Fifth, streaming one-pass algorithm, Welfo algorithm for the mean and variance. Sixth, approximate sketches, T-digest or Q-digest for the quantiles. Seventh, partition aggregation, compute partial statistics on partial thread and then merge the mean and variance. Eighth, reservoir sample for the random sampling of data set is too large to store. Then compute exact measures. The last one, historical histograms and the bin common counts for coarse approximation of distribution and median. Second, sorted evidence scores 1 to 100 extracted from complaint text. Sorted values 13, 15, 16, 19 goes to 70. First question, what's the mean score and what's the median? Second, what are the mode? What is our mode? Comment on the modality. What is mid-range? What estimates Q1 and Q3? Give the five number summary and draw box plot of the scores. And in this context, how is a quantile to quantile plot different from a quantile plot? Example, to check if the evidence score follows a target distribution assumed by DNS. We start with the question number one, find the mean and median. We find the mean by the sum of values divided by the number of values. We get the value of 29.96 and we calculate the median as the middle of the 27th value is the 14th value is 25. Now we calculate mode or modality. Frequency 25 appears 4 times, 35 appears 4 times, 16 appears 2 times, 20 appears 2 times, 22 appears 2 times, 33 appears 2 times, and other ones. The mode is 25 and 35. Both has the highest frequency of 4. That's a bimodal distribution. The modality is bimodal. Third question is to calculate the mid-range. Mid-range is minimum and maximum value divided by 2. So we have the answer 41.5. Question 4 to calculate Q1 and Q3. Usually the Using the usual 25 and 75% simple quantile interpolated, Q1 is 20.5 and Q3 is 35.5. So the IQR will be Q3 minus Q1, that will be 14.5. Third, we have to calculate the 5 number summary. The minimum is 13, the Q1 is 20.5, median is 25, Q3 is 35, and max is 70. Next, we have F to calculate the box plot. Box plot from 20.5 to 35 with a median line of 25, IQR 14.5. Whisker using a normal rule 1.5 into IQR that gives us 21.75. Lower fence Q1 minus 1.5 into IQR that gives us the value of minus 1.25. No lower outliner, lower whisker minimum equals to 13. Upper fence to Q3 plus 1.5 multiplied by IQR that gives us the value of 56.75. The value is greater than If the value is greater than 56.75, our outliner 70 is the outliner. The upper whisker is the largest non-outliner, which is 52. So the odd box plot shows a cluster of 20 to 35 range, a long right tail, and one clear outliner at 70. The next part is question number G. To plot G to G plot versus quantile. To have to differentiate between them and to find the uses. Quantile plot level probability P on X versus a simple quantile value XP on Y. It shows the data, how the data quantiles changes with probability useful to visualize the distribution shape, Q-ness or plateaus. QQ plot quantile to quantile plots quantile of the sample against the quantile of the theoretical distribution, example normal or under sample. If the sample quantile align roughly on the 45-degree line, sample follows a theoretical distribution or matches no other sample. Use the QQ test to whether evidence score follow a particular target distribution assumed by DSS, and use quantile plot to visualize the distribution form itself, like skew or multimodality, without directly comparing to the difference distribution. Third, we have severity index distribution bin from the extraction of the complaint featured is shown below. Severity range 1 to 5, 6 to 15, 16 to 20, 21 to 15, 50, 51 to 80, and 81 to 110. We have the frequency given as 200, 450, 300, 1500, 700, and 44. Okay. The total number of cases is 3194. The median will be 1597th position or the 7 observation as a median. Cumulative frequency by the bin is given like this. The median lies in the range of 20 to 15 bin. Interpolate inside the median bin. The lower class bound L is 21 and the class width is 30. Cumulative bin before bin is 950 and bin frequency is 1500. The median L plus n by 2 minus cumulative before by f bin with 21 plus 1597 minus this gives us the value of 33.94. Approximate mean severity is 33.9. Okay. Interpolation is a typical complaint severity is in the range of 30 to 35 range. Fourth, we have a district intake, sample records, complainant age, and self-assessed incident impact percentage for 18th complaint. So we have given the ages of 23, 27 till 61, and then the percentage of the incident impact given for the each values. So data, the n equals to 18, so 18 number of the complaints for file. Impacts percentages were given. Now we are computing the mean, median, and standard deviation. We know the formula of mean, and the mean will be equal to 46.44. The median age will be sorted the average of ninth and 10th. That will be 50 plus 52 divided by 2, 51 years. 51 years. Sample standard deviation will be 13.2 years. Impact percentage, no impact percentage. The mean impact percentage will be 28.78, and the median impact percentage will be 30.70. The average of ninth and 10th. Standard deviation will be 9.25 with a formula given under below. Part B to plot the box plot interpretation outliner. The age plot was Q1 40, Q3 56.5, and IQR will be 16.5. Lower fence Q1 minus 1.5 minus IQR will give us the result of 15.25, and the upper fence will be 81.25. No outliner as all the edges lie within the fence. Box between 40 and 56.5, median with the 51, and a whisker will be from 23 to 61. Impact percentage box plot. Q1 will be 26.85 and Q3 will be 33.75. IQR will be with the IQR of 6.90. Lower fence will be 16.50 percentage and the upper fence will be 44.10 percentage. The outliners 9.5 percentage and 7.5 percentage are below the lower fence. Implies that too low outliner, a very small self-assessed impact. Other values lie between the fence upper whisker 42.5, the largest outliner, and the box between 33.75, and the median will be 30.7 percentage. The part C in this we have the scatter plot or the Q2Q plot with to study relationship. Scatter plot age on X and impact percentage on Y, visual relationship for these data. The Pershing correlation R will be 0.8.8, the strong positive correlation. Interpolation. Older complaint tends to report higher self-assessed impact percentage in the sample. On a scatter plot, you will see plots roughly following are an upward trend. You could fit a regression line impact percentage A plus B dot H to summarize the trend. Q2Q plot or Q2Q for normality. Draw QQQ plot for ages versus normal quantile and impact percentage versus normal quantiles to access the approximate normality. Ages, some left is Q, and a couple low ages like 23 reduced mean. Check if the points roughly online. If so, normal approximation is okay. Percentage impact. Presence of two low outliers 7.8 and 9.5 will produce departure in lower tail on QQ plot. Points below the line. QQ between variable. You can also Q and Q variable versus another less common to check if they share distributional shapes or not. Now we start with the part B of this internal paper, similarity and dissimilarity in the feedback. Starting with the fifth one, briefly outline how to compare dissimilarity between students' feedback profile described by A. Normal attributes, department and elective chosen. B. Asymmetric binary attributes, attended workshop, yes or no. C. Numeric attributes, example CGPA or percentage attendance. And D. Term frequency vector, keywords in the open text feedback. Starting with the A1, normal attributes. Example, jurisdiction, police station, offense category, etc. Dissimilarity rule, if the value matches, distance equal to 0. If the value differ, distance plus 1. General formula for K nominal attributes is D, I, comma J, number of mismatches by total normal attributes. Notes, we have use simple matches coefficient alternative, assign a cost matrix if some mismatches are more serious. Part B, asymmetrical binary attributes. Example, criminal force present, property damage present. Presence and absence of offense element. Here, 1 equals presence and 0 is absence. Use Jacquard distance. Let the Q be the position where both are 1, R be the position where I is 1, J is 0, and S is the position where I is 0 and J is equals to 1. Jacquard similarity is Q by Q plus R plus S. And Jacquard distance is 1 minus Q by Q plus R plus S. That's Jacquard similarity. Part C. To calculate the Marek attributes, example, we have the incident duration in minutes, estimated loss in rupees, we have age, count, and severity score, distance, use equivalent math with the formula of summation of xi in mod, xi minus yi in mod. Minkowski will be D, we have the formula of D, summation xi and yi in the mod to the power of h and whole to the power of 1 by h. Preprocessing normalized numeric values that score a minimum max to avoid scale imbalance. The D part term frequency vectors from FIR text, keywords, entities, or FNs element represent complaints and TF or TFIDF vector. Distance measure cosine distance D equals to 1 minus x dot y is to mod of x and mod of y. Equivalent on TDF, TF or IDF or Jacquard for sparse bag of words. Now the question 6 we have, suppose two student faculty interaction profile are represented as a tuple in which we have 22, 1, 42 and 10, and second tuple we have 20, 0, 36 and 88 where the attributes represent hour spent in monitoring, project reviews attended, assignment submitted, infrastructure users count. You have to calculate the equilibrium distance, Manhattan distance, Minkowski distance when h is 3, and supermum distance. Now, let's start. Distance computation between tuple. We have given two tuples. We define them as A and B, representing incident duration, witness present, number of witness incident, and alleged acts count. Let's compute. We start with the first one, equilibrium distance. Calculate the equilibrium distance. We know the formula to calculate that x1 minus x1 minus x2, x2 minus x1 ka whole square minus y2 minus y1 ka whole square, and compute this till the last value. So here we have the answer to be distance of grid distance will be 6.708. Now to calculate the Manhattan distance, we calculate it using the mode of subtraction of first value to second value, the first value of the other one, and similar till the last value. And now we get the answer of 11. Minkowski distance when h is equals to 3 will be 6.13. And supermem distance, She B chef distance will be D max xi minus yi mod the max. So the difference of this in the max will be 6. In question 7, we have median score is often a key holistic indicator of faculty or infrastructure performance. When dealing with a massive student feedback dataset, proposed proposed method for median approximation, analyze their complexity and suggest heuristics to balance accuracy versus efficiency. Third, median approximation in large dataset. Median is robust for triage. An exact median is expensive for massive dataset, million of complaints. So the approximation methods that's we're going to use, starting with the first one, GK quantile summary, Greenwald Khanna. This maintains a E approximate quantile summary, and the space complexity of this is O is to E1 log En. Mergeable implies works in distributed DSS. Second, starting with the second one, TJS. This maintains centroid with a small variance, where very accurate around median. Space complexity is less than 5 KB for million of points and mergeable, map reduce friendly. Starting with the third one, reservoir sampling. A sample K observation uniformly form streaming complaints. Compute median on sample. Error is proportional to 1 by root of K. In this slide, we are given the time and space complexity summary. We have method of one column, time complexity of one column, space complexity on one column, and the accuracy on another column. For exact sorting, the time complexity is given, and the accuracy I'm going to explain is exact. For GK summary, accuracy is approximate. For TZS, the accuracy is high, and for the reservoir method, the accuracy is medium. Heuristics use GK or T-JARIS for accuracy, use reservoir sample for exact or extreme scale. For distributed system, combine partial summaries and always remove outliers before computing median. So starting with the question number 8, consider student-faculty similarity analysis, a sample data set of two attributes. We have faculty responsiveness, infrastructure support. We have two attributes given in the data set. So we have a student 5 student S1, S2, S3, S4, and we have A1 as the first attribute and A2 as the second attribute. Given a new feedback query X 1.4 and 1.6, first we have to rank existing student feedback profile by similarity using Euclidean, Manhattan, and Superman cosine similarity. Second, normalize each student vector to unit length and recompute using Euclidean distance. So we start the solution. Ranking complaint using multiple similarity measures. Query vector we have name it at x, we have 1.5, comma 1.6. Let's compute distance to each complaints. Starting with the first one, to calculate distance between Euclidean, Manhattan, and Superman and cosine similarity for complaint C1. That is 1.5, comma 1.7. Euclidean distance will be 0.141. Manhattan distance will be zero point 0.2. Superman will distance will be zero point 0.1 and cosine similarity will be 0.998. To calculate, and the formula of this are what explained in the previous slides. For C2, the accurate distance will be 0.671, Manhattan will be zero point 0.9, Superman will be zero point 0.6, and cosine similarity will be 0.95. For C3, the accurate distance will be 0.283, Manhattan will be zero point 0.4, Superman will be zero point 0.2, and cosine similarity will be 0.992. For complaint C4, the accurate distance will be 0.224, Manhattan will be zero point 0.3, Superman will be zero point 0.2, and cosine similarity will be 0.978. For C5 will be equidistant will be 0.608, Manhattan will be zero point 0.7, Superman will be zero point 0.6, cosine similarity will be 0.93. Now we come to the concept of similarity ranking. Euclidean is smaller but more similar. We have C1, C2, C3, C4, and C5 given. Manhattan same order as Euclidean. Superman same order. Cosine larger, more similar. So C1, C3, C4, C2, and C5. And the part B, normalize all. The part B, normalize all the vector to unit vector and recompute the equidistant distance. Vector length will be mod between a comma b, calculated by the formula of under root a square plus b square. Next, we have to normalize all the complaints. Below are the results computed. You complete one C1, C2, C3, and C4 and C5, and we have the normalized vector F1 and F2 given below in the table. The computed equilibrium distance from X dash will be given as below. The final normalized ranking will be C1, C3, C4, C2, and C5. Question number 9. To discuss accuracy, completeness, and consistent issue, missing timestamps, contradictory narratives, mistyped sections, propose two more qualified dimensions relevant to legal analytics, timeliness and verifiability or provenance. There can be various examples illustrating that the assignment of data quality can depend on intended use of the data. Here, we just give a few. For accuracy, first consider a recommendation system for online purchase of clothes. When it comes to birth date, the system may only care about in which year the user was born, so that it can provide the right choices. However, an app in Facebook which makes birthday calendar for friends to acquire the exact date on which a user was born to make the credible calendar. For completeness, a product manager may not care much if the customers' address information are missing, while a marketing analyst consider address information essential for analysis. And for consistency, consider a database manager who is merging two big movies information database into one, whether when he considers whether two entries refer to the same movie, he may check the entries at titles and release date. Here in either database, the release data must be consistent with the title or there will be annoying problems. But when a user is searching for a movie information just for entertainment using either database or whether the release date is consistent with the title is not so important. A user usually care more about movie's content. The two other dimensions that can be used to access the quality of the data can be taken from the following: timeliness, believability, value-added, interpretability, and accessibility. These can be used to access the quality with regards to the following factors. Timeliness: data must be available within a time frame that allows it to be useful for decision making. Believability: the data values must be within the range of possible results in order to be useful for decision making. Third, value added. Data must provide additional value in terms of information that offset the cost of collecting and accessing it. The last, interpretability. The data must not be so complex that the efforts to understand the information it provides exceeds the benefit of its analysis. Next, we have question 10. In this, for handling missing values and extracted feature, discuss approaches, ignore tuples, manual completion, and constant fill, mean, median, mode imputation, class-specific imputation by offense category, and most probable value, the model-based. The various methods for handling the problem of missing values in data tuple include ignoring the tuple, B. Manually filling in the missing values, C. Using a global constant to fill the missing values, and fourth includes using a measure of center tendency for the attribute, such as mean for symmetrical numerical data, the median for asymmetrical numerical data, or the mode for nominal data. For example, suppose we have the average income of all electronic consumers is $28,000 and that data is symmetric. Use this value to replace any missing value for incomes. The two other methods are using the attribute mean for numerical or quantitative values or attributes mode for nominal values for all sample belonging to the same class as the given tuple. For example, if the classifying customer according to the credit risk, replace the missing value with the average income value for customer in the same credit risk category as that of the given tuple. If the data is numerical or skewed, use the median value. Last, using the most probable value to fill in the missing values. Then this may be determined with regression inference-based tool using Bayesian formalism or decision tree induction. For example, using the other customer attribute in your dataset, you may conduct a decision tree to predict the missing value for the income. Now moving on to the 11th one, Smoothing extracted score. Use the evidence strength list from A2. First A. Smooth using bin means and bin depth. 3. Show steps. B. Suggest ways to detect outliner. Rare, very high impact with low evidence. C. Discuss other smoothing method. Bin medians, LOESS, moving averages, robust estimates. Smoothing evidence strength score. Starting with the first one. We use evidence strength score from part A2, sorted list of 27. We have 13, 15, 16 goes on to 70. A, starting with the question number A, smooth using bin mean with bin depth 3 is the best of starting interpretation. Group sorted list into the consecutive bin of 3 items each and replace each value by its bin mean. We compute 9 bin, 1, 2, 3, 4, 5, 6, 7, 8, 9, and and the mean value of each bin respectively is 14.67, 18.33, 21.0, 24.0, 26.67, 33.67, 35, 40.33, and 56 respectively. Smooths the series, each original replaced by its bin mean. Okay. Note: smoothing reduce local noise and emphasize the broad structure. Use rounding to approximate the precision for the system. The part B, detecting outliner, very rare high impact with low evidence approaches statistical rule, IQR rule, value of greater than Q3 plus 1.5 into IQR or less than Q1 minus 1.5 into IQR. That is score. The mod of Z has to be greater than 3 as an outliner. Robust method, mean median absolute deviation MED. Points with X minus median is to MED has, has to be greater than threshold trigger or threshold flagged. Model based residual. Fit expected impact from feature, example regression using ground, fitness presence, object type. Large positive residual impact is much greater than the predicted evidence are suspicious. Fourth, density or the local outliner factor LOF. The points with much lower local density than neighbor LOF much greater than 1. Fifth, rule-based domain heuristics. Very high financial loss with zero evidence or no witnesses implies flag. Sixth, uh, cross-source corroboration. If the claim is high impact but no matching record in EFIR, forensics, or CCTV, marks unverifiable. Seventh or the last one, actions when an outliner is rejected. Mark for human reviews, legal vetting, attach provenance check, and maintain separate treatment in modeling, robust method, or downweighting. Other smoothing method includes, we're going to conclude the brief pros and cons. Bin method, instead of mean, more robust to outliner inside the bin, useful if the last bin has extreme 70. Second, moving average or rolling window. Smooths locally, window size controls smoothness. Third, lowesses or lowesses, locally weighted regression, non-parametric smooth capture local trend, good if the non-linear trends exist. Fourth, kernel smoothing, Gaussian kernel, weighted average with the kernel weight dropping with distance. Fifth, robust estimation, Huber or Turkey, reduce influence of outliner during smoothing. 6. Exponential smoothing for time series of evidence values if chronological. 7. Quantile smoothing or median filter. Remove spikes while preserving edges. Recommendation for tree edges, bean median or tree edges for the quantile are robust choices. Lowest for the useful for reporting and visualization. Starting with the fourth one, discuss schema integration and handling redundant entities, that's duplicate across e-file or physical log, and resolving value conflict, example differing monetary loss or section labels. Schema integration, duplicates, and conflict resolution. Scenarios: suppose a scenario that we have a complaint from multiple sources: EFIR, physical FIR log, lab reports, CCTV metadata. So starting with the explain the first topic. Scheme integration. Conical scheme. Design a global complaint scheme with a conical field, incident ID, data time, location ID, complaint ID, accused section, estimated loss, evidence count, narrative text, provenance, and a mapping layer, source to conical mapping, ETL, for each input field, include field conversation and unit harmonization. Use conservative uncontrolled vocabularies for offense coding. B. Duplicate and redundant entities. Record linkage and deduplication. Use a composite similar key, victim name plus minus fuzzy matches, date or time window plus spatial proximity, complaints narrative similarity, and unique identifiers. Second, use a probabilistic record linkage, village center, or trained pairwise classifiers. Features name similarity, time difference, location distance, and same accused. Second in this, merge strategies. If the duplicates are found, merge them into a master consolidated date record and preserve all sources version in provenance. C. Resolve value conflicts. Example, differing monetary loss or section labels. Provenance weighting. Associate each source with a test confidence score. Official policies has to be greater than citizen portal entry and has to be greater than third party. Conflict policies, numeric conflicts and the categorical conflict are the two types. Take most reliable source or the compute consistent, that's median, and keep all original. In categorical conflict, use source precedence or vote across sources if tied, set to ambiguous and require legal review. Audit trail, store original values, chosen canonical values, and reason and algorithm for resolution. Question fifth, explain normalization method for feature scaling. With the first one, minimum and maximum normalization. B, Z-score normalization. C, Z-score using mean absolute deviation. And D, decision scaling. Normalization method for feature scaling, definition, formulas, pros and cons are given in the answer. Given a numerical feature x with the observed minimum x mean, maximum x max, and the mean as mu, and standard deviation as this symbol. Starting with the first one, minimum maximum normalization, that's rescaling. We calculate x x complement as x minus x minimum by x max minus x minimum, range 0 to 1, or map to in square bracket a comma b. Pros, it has a benefit or the advantage of minimum and maximum normalization. Preserve the original distribution shape, good for the boundary algorithm. Cons, sensitive to the outline and new values outside the training and the minimum max requires clipping or rescaling. Second one, Z-score normalization or standardization. Let the formula of x complement as x minus mean by standard deviation. Properties, mean is 0, standard deviation is 1. Pros include handle unbounded features, robust for algorithm assuming Gaussianity. Con, sensitive to outliner if the distribution is skewed, transformed value may be misleading. C. Z-score using mean absolute deviation MAD. The formula of this is x complement will be x minus mean divided by MAD, where MAD has the formula 1 by n summation of xi minus mean, where goes from I equals to 1 to m. Pro include MAD is more robust to outliner than standard deviation in some contexts. Con is still affected by the distribution skew, choice of center matter. Alternate robust standardization use median and MAD. The D1 decimal scaling. X complement will be x by j to the 10 to the power j, where j is chosen so that x complement will be less than 1. Pro includes simple and preserve order. Con includes arbitrary scaling, rarely used in ML practices. So which to use in the company analytics? So it comes in the nose format. For robust scoring, where outliner exists, monetary laws use median plus MAD standardization or log transform, then standardize. For features that are naturally bounded, percentage use min and max. Starting with the sixth one, question 6, binding. Case severity scores goes from 5, 10, 11, 30, 35, 50, 55, 72, 92, and till 215 partitioned into A equal frequency bin, B equal width bin, C clustering kind of based bin, and also explain the implication for section mapping threshold. Given a score as given, we will partition into three bin to illustrate equal frequency, equal width, and k-mean clustering. So we partition them into three bin. The number of data that we were given was 12. So we divide them into 4 each. To divide them into three bin B, EF1, EF2, and EF3. Okay. Implication: each bin has the same count, good for the balance training, thresholding. However, thresholding boundary are data dependent and can place very different severities together. Example 15 with 55. B equal with bin. We calculate three bins, we have three bins. Ranges minimum minus maximum will be 125 minus 5 will be 210. Minimum with VW 210 divided by 3 will be 70. That's the bin width. The bin W1 will with the value of 5 to 75. Bin 2 has the value of 75 to 145 and the value will be 92. And the bin 3 will be 145 to 115. 215 that gives the value of 204 and 20215. Implication: first bin contain the many low mid cases. Second bin almost empty and third bin contain extreme. Balanced. Good if you want to absolute cutoff. Example, any score has to be greater than or equal to 144, flagged as high severity. C. Clustering based bins. K mean or K equals to 3. A simple K mean style partition, controlled and assignment, a possible partition by usual clustering. We make three cluster, cluster 1 no, cluster 2 medium, and cluster 3 high. The centroid of the each cluster will be 14.83, 1367.25, and 209.5 respectively. Implication will be cluster capture natural grouping and separate extreme outliner, and this is often preferred for settings section mapping thresholds because it reflects natural breaks in data rather than forced equal counts of width. Effects on this section mapping threshold: equal frequencies. Threshold are data percentiles based, good for balanced workload allocation, but may map legally different severities to the same action section, equal with operational or absolute threshold. Clustering, natural grouping that align with real case separation, good to set threshold with clustering cluster separate and then evaluate the legal aspects. Recommendation: use clustering or quantile plus domain check to set initial threshold, then validate with legal SMEs and historical map accuracy. Starting with question number 7, we have to explain feature selection for section mapping and summarize with a flowchart that techniques for choosing attribute used by DSS. Starting with the first one, forward selection, backward emulation, and the hybrid methods. Okay, now we start. We have the goal to choose a compact predictive subset of a feature for DSS that maps complaint, IPC, and DNS section. Candidate feature example: you can take evidence count, witness present or not, monetary loss, yes or no, incident duration, weapon present, yes or no, offense keyword, location type, complaints, age, accused history, flag, and provenance scores. Selection technique, starting with the first one, forward selection. Start with an empty feature set. Iteratively add the feature that most improves the validation performance. Example F1 or accuracy until no significant improvement or budget reached. Pros: cheap early and find small sets. Cons: can miss interaction or be greedy. The B1 backward elimination. Start with the full feature set. Iterative remove the least useful feature based on drop in performance until removal harm performance beyond tolerance. Pros: considers interactions. Con: expensive when the feature set is large. C. Hybrid, stepwise. Combination of forward and backward add feature, occasionally remove the previously added ones if they become redundant. Pros: balance cost and ability to handle interaction. D. Filter methods. Use univariate meshes, chi-square, or mutual information, or ANOVA effect scores to pre-select features. E. Embedded methods. Regularized model lasso that shrink coefficients to zero, tree-based feature importance, random forest or XGBoost rank features. F wrapper method use classifier as black box or search subset. G dimensionality reduction. PCO SVD for numeric feature or truncated SDV for TF or IDF text feature. So this was the explanation on the solution of first internal of data science using Python.